All right, we're gonna have to make this happen here. We're in the blended learning room, and we are gonna look at Unit 3, and we're gonna talk about systems of equations. Are you ready, everybody? The foundations of algebra. Now I just updated that first assignment. Yeah, the solving equations unit test. So as you know, that one, you should already know how to do all of this. So I'm not going to include any examples from this, but feel free to put them in the organizer. And let's start out with solutions. Is everybody having a good day? Solutions to systems of equations. So what is a system? A system of equations is two or more equations. So let's write that down. System implies two or more equations, and they're connected. So like they could be on the same graph, have a double table, they are related. And so a solution to a system means the ordered pair. I'll just write the XY, I was going to say work, but I'm going to say a better word, satisfies both equations. So, an ordered pair, like this guy right here, is a solution to an equation if it satisfies the equation, right? And so it's a solution to the system if it satisfies both equations. Makes sense, right? So let's see if this one works. As you can see, I already did a couple. 4, 2. So let's substitute 2 in for y and 4 in for x. And 4 minus 2 is 2. And so we see that, yes, 4, 2 satisfies the first equation. And the second equation, substituting 4 in for x, that would be 12 plus 4 is 16. And then 2 in for y. If I did my math right, 2 and 16 are not equal. Well, we know that. So it's looking like that does not satisfy that equation. So we're going to say no. And we're right. All right, so that's that one. Solutions to a system. Substitute. And solve. And see if you get the same thing on both sides. Now, as far as this one, solving systems by graphing. When you are graphing, well, you could be graphing in slope-intercept form or standard, right? Point slope. If you're in point slope, then I guess that's kind of like slope-intercept. You're just not starting at the y-intercept. But in any case, you have to know what form you're in, all right? And then you can graph it. So what form are these guys in here? Those are in slope-intercept form. So we're going to use our slope-intercept strategy. And I'm just going to write them down. So when I scroll down, you can see it. So, all right, so we got negative 5x plus 6. So when I graph that, where do I don't know, how do I guess negative 5x plus 6. So I'm going to put a 6 there. Then negative 5 means I'm going to go down 5 and over 1. And then what's the other one? 3x minus 2. So that means 3x minus 2. 3x minus 2. So that means I'm going to start at negative 2. And then I'm going to go up 3, right 1. And we can see that those lines intersect. Did I say that yet? The solution is where the lines intersect. And they intersect right there at 1, 1. So what we could do is we can write 1, 1. So the solution to a system, not only does it satisfy both equations, but it's where the lines intersect. Make sense? So now we've done 2. All right, now this one is tough. So put all your red questions and then let's have a great conversation about creating systems in context. Okay. So I'm going to read through this one and I'm going to circle the units. That's the first thing I want to do. I'm not even reading it yet. I'm just circling the units. Okay. And then we have hours, distances. So our quantities are time and distance, right? And our units are kilometers and hours. And those units are going to help us, well, know what the variables represent. And they're also going to help us set up our equations. So let's read this. Aaliyah rode her bicycle from her house to the beach at a constant speed of 18 kilometers per hour and then rode from the beach to the park at a constant speed of 15 kilometers per hour. The total duration of the rides was 1 hour and the distances she rode in each direction was equal. Okay. Let B be the number of hours it took Aaliyah to ride from her house to the beach, and P be the number of hours it took her to ride from the beach to the park. Which system of equations represents this situation? So let's go ahead and look at, we know that there's equal distance, and we also know that it took her 1 hour. Okay, so I'm looking for the total duration of the rides was 1 hour. So we want to choose the one that says B plus B equals 1. And that's because when you add the rides together, it equals 1 hour. Now, if I'm wrong, I'm wrong. And then the other thing we know is that the trips were equal. So 18 is from the beach to the park, and B is the hours it took to ride from her house to the beach. Road from the house to the beach. So 18B. So this one right here has 18B, and we know that when she was riding from the beach to her house to the beach, she was riding at 18. So I'm thinking that. All right, let me just talk more about this. So we know that she was riding and that these distances were equal, so they're equal to each other in the equation. And then we also know that it took her 1 hour. So if you add those variables together, which is the time, it equals 1 hour, adds to 1 hour. Okay, so I fully expect you guys to have a lot of questions about this one, but just to get you started, look at the units and try to set up your equations and have a rationale about what the equation represents. Okay, so now let's go to interpret points, another kind of tricky one. But these are really important to help you actually use this stuff. All right, so Chana, and Josiah started skating at the same time in the same direction. So again, I'm looking for the units. I know we got talking about time here. Josiah had a head start 10 meters past the starting line. Chana skated 3 meters per second, and Josiah skated 2 meters per second. So what are the units? Meters, seconds. Okay, what do the variables represent? X represents the number of seconds Chana and Josiah started skating, and Y is the distance from the starting line. Okay, so X is time, Y is distance. And so what does this point here represent? Okay, so again, X is time, so we know that this is 5. Those are seconds, the minutes. I don't remember, seconds. Okay, so this is 5 seconds here. So at 5 seconds, we have 2 lines. We have the 3x and we have the 10 plus 2x. So which line represents which person? Well, who's skating at 3 meters per second? Chana. Okay, so this is Chana. And this is the other guy, Josiah. All right, so the line that's under means that that person, if this represents distance, if the line is underneath, like this blue line is right here, that means that Chana is not as far along as Josiah at 5 seconds. we see right here at 10 seconds, they're at the same distance. And after 10 seconds, right here, Channa has taken the lead. I'm going to write lead right there. But before 10 seconds with his head start, Josiah was in the lead. So let's see what we can choose. We know that Channa is not as far as Josiah. From the starting line to the time, okay, Channa's distance from this, so we know it is talking about Channa's distance because it's on the blue line. At the time when she's behind Josiah, that's the one. She's behind Josiah because she's not as far along. Okay, so a lot of fun you can have with those, and hopefully a lot of good conversations in class. But now this is another one that you may be able to do, before you get to class, because substitution uses a lot of the skills that we've already done this year. So we've looked at a solution to a system, we've looked at how to graph it, and this one is solving it algebraically. There's more than one way to solve algebraically, but this way is called substitution. So get ready, write this down, and let's go. When you solve using substitution, we want one equation in slope-intercept form. Okay, so you might need to rearrange to get there. And then we circle the mx plus b and substitute into other equation. Then we solve and sub answer into other equation and solve for other variable. I know my handwriting is terrible, but this pen is not working. Okay, so which one of these two is in slope-intercept form? Well, really neither, but this one has solved for x, so we're just gonna, that's close enough. That's gonna work. So I circle the mx plus b part, or the my plus b part in this case, and we're gonna substitute that in right here because you see it says x equals. So that means we can rewrite this equation, but instead of 2x, I'm gonna write 2 negative 6y plus 7 minus 9y equals 14. All right, hold on one second. And I want you to notice what that did. That gives us just one variable now, just the y. So we are going to solve for y. So I'm going to distribute negative 12y plus 14 minus 9y equals 14. I'm going to combine my like terms, which would be negative 21y. And put my numbers on the right, so that's going to be 14 minus 14, which is 0. And then negative 21y equals 0. So then, y equals 0. Okay, can't write it there. Fine, I'll write it here. So y equals 0, we got that. So then what does x equal? Well, we see right here that in our mx plus b type of equation, I can just substitute my answer in and easily find the value of x. And it's always going to work like that. So that goes away, and the answer is 7. So now we know that x equals 7. All right, so it's a lot of work, but in the end, not too bad. All right, so goodness gracious, there's a lot. Not going on here. There we go. So y is 0, x is 7, and there we go. Okay, so that is the substitution. One more time. You're gonna make sure one of them is in slope-intercept form. You're gonna circle the mx plus b part. Substitute that into the other equation, solve for your variable, take your answer and substitute it back into the slope-intercept equation, and then you have both variables, and you'll be done. All right, so hey, give that a try, give the graphing a try, solutions, and then we can spend the bulk of our time in class on the interpreting and the creating systems in context. I'm so excited. Can't wait to see you guys.